Hey everyone, whoever's watching this, my name is Mohammed Awan from BN420 part-time student. Alright, welcome to this presentation. So we'll get started. Right, for this presentation, for this experiment, the resources I used for my MHN server are Ubuntu 18.04 with a RAM size of 4 gig and 80 gig of space disk. I used the $20 per month package. They were from DigitalOcean. I also enabled $4 per month for backups. The location I chose for United Kingdom because it's closer to me for better connectivity for my honeypot service. Again, the Ubuntu 18.04 with a RAM size of 1 gig and a disk space was 25 gig. I chose the cheapest option there on DigitalOcean for my honeypots, which was $5 per month, with $1 for weekly backups. Again, the location was United Kingdom. Right, the honeypots that I deployed were Cowrie, Snort, Suricata, and Shockpot. Cowrie, I went for Cowrie because it's a well-known sensor. Cowrie is a medium to high interaction sensor which basically supports SSH and Telnet protocols. This sensor is designed to basically log brute force attacks as well as basically monitor how the attacker interacts with the shell. The second sensor I chose was Snort. Now Snort is different from Cowrie. Snort is an IDS system which basically is capable of capturing real-time traffic and packet logging. Suricata is also similar to Snort. It's also an IDS, another IDS system, but in addition to that, it also is capable of inline intrusion prevention, network security monitoring, and it also tracks SSL and TLS sessions. Now, the number you see here, the big number, these are the attacks I gathered over a month and a half. So I kind of took this screenshot around 4 days ago and had over 1 million attacks. So the honeypot database, basically, as we know, MHN works with MongoDB and uses the HP feeds and session tables to store the primary data from our honeypots. Data from each honeypot is basically aggregated onto the server with the MongoDB instance. We can also use a custom bash script to basically dump weekly, monthly, or whatever days intervals we use to basically back up our data for other archival purposes, etc. Right, so moving on to findings and analysis. As we can see in this graph, the top attacking countries, no surprise, Russia is at the top because Russia is part of the big four. The other three countries are China, the United States, and Iran. For our attacks, basically, Russia had the most attacks with 410,000 attacks. Germany being the second with 62,000, and United States with 30,000 attacks. As you can see, I deployed my Honeynet around mid-October, and I took screenshot around December 3rd, I think, December the 2nd here. And as you can see, on average, I was getting around 2,150 attacks per day. But you might notice we have few high peaks here. So these peaks are basically caused by IP addresses. There's four different IP addresses that caused these peaks. So basically, I looked at those IP addresses on Abuse IPDB. And what I found was that each one of them was reported for malicious activities. One of them was from Uruguay, another one China, two of them were from Netherlands. And as you can see, the last one here over on the right hand side was reported 461 times and with a confidence of abuse rate at 24%. So all of these peaks here, as you can see on Monday 22nd of October, was caused by one of the IPs. The second peak we have here in Monday 25th of October was caused by the second one, second IP, the third one here, and the fourth one at 10th of November. So moving on to the top commands used by the attacker. When an attacker gets in, what do they do? Well, basically they use commands to basically look into our system. And as you can see in this graph, the top command that was used was echo. Now this command is basically used to output text. Now for whatever reasons they use this command. Now uname command was also used. And this command, what it does is basically reports basic information about a computer software or hardware. So they probably use this to retrieve information about our honeypots that they thought was a proper system. Now, the top username and password used by the attackers. No surprise, we have here nproc 452 times that was used. We also have admin that was used 82 times. We also have support as a username and password support as well, which was used 21 times. Now we see on daily basis people use a really easy password, which basically puts their network, their data on at risk. Okay, so top IP attackers. As we can see here, the top 10 attackers, 9 out of 10 are shown as from Russia, but in fact, these are actually not all from Russia. However, in most cases, the IPs used are obfuscated to mask the true attackers. So what I did was I looked up these IPs, the top ones, just for an example, and they're not actually from Russia. They're from Ireland here. That's one of the IPs I searched, and that's the second one I searched, and it's also from Russia. So this basically tells us that the attacker kind of masked themselves to attack, to basically show their attacks coming from a different country. So moving on to the top URLs used. As you can see here, the top URL used by an attacker was an IP address 192.99.44.183. I also looked this up on Abuse IPDB website, which basically tells you if an IP has been reported for malicious activities. And with 100% abuse rate, yes, this IP was reported 427 times. Again, a suspicious IP which was reported. So moving on to the next top 10 signatures, basically. As we can see in this graph, we have a top signature of ET-drop D-Shield, which alerted over 22,000 times. What this does is basically triggers alarm. It triggers alarms. So this alerts an alarm for an inbound traffic whenever it matches an IP from a drop D-Shield block list. The D-Shield collects data about malicious activities from the internet. So whenever there was a match, it basically alerted us. Now the second one is ET scan suspicious inbound to MS SQL port 1433. Now this alerted of just over 13,000 times. This is from Snort Honeypot. Snort sees the traffic before the firewall rule, so it alerts on things that are blocked by the firewall. In this instant, it basically alerted us just over 13,000 times. I know we're running out of time here. I'll quickly go through the rest of the findings I have. Well, we have top destination ports attacked, as we can see here, port 1433, which is basically default port for SQL Server, which was attacked just over 6,000 times during the period of the whole experiment. The second place goes to the SSH port 22, and so on. So that's it from me. Thank you very much for listening. I hope this all made sense. And if there's any questions, just let me know. Thank you very much.